Hey everyone, it's Actuary Dude over here looking at another question. So an investment project gives rise to the following cash flows at the beginning of each of the first 3 years. £180,000 will be invested in the project. And from the beginning, again, of the first year until the end of the 25th year, net revenue will be received continuously. The initial rate of payment of the net revenue will be £25,000 per annum, so it'll begin there. The rate of payment is assumed to grow continuously at a rate of 6% per annum effective. So what is the net present value of the project with an effective interest rate of 7% per annum? So the net present value, fairly straightforward, the first bit. Just finding we're getting £180,000 that we're paying, like that. And it's a negative amount and at the start of each year, so we're doing that over 3 years. So we're using annuity due, and that's fairly straightforward. But now this bit over here is that we're actually receiving £25,000 and we're receiving it continuously over 25 years, but it's also growing continuously. It's growing at a rate of 6%. So how do we solve what that is? It's a 5 over there. So this bit over here, our continuous annuity there is actually going to be following this kind of formula where it's going to be going 1 minus, and it's 1 plus the growth rate over 1 plus the interest rate, and the growth rate is 6%, so 1.06 divided by our interest rate, 1.07. So that's V right there, as per usual, as we would usually put it in as V. And then we're putting it all over delta, and we'll find out what delta is. Now, if this is V over here, so V is equal to 1.06 and 1.07, and that's also equal to 1 divided by 1 plus I, well then this I over here, and that's what we're going to be using to find out our delta, which is 1 over 1 plus I. So that bit's equal to delta. And so these i's are the same, that one there and this one here. And so now all we have to do is just use Excel over here to find out what the net present value is going to be equal to. And so let's solve that bit right here and say, alright, first bit is we've got an interest rate of 0.07, so we can find out that V, we're going to need D as well. So V is equal to 1 divided by 1.07, and D is equal to 1 minus that over there. So let's just find out what our first bit is. So we've got equal negative 180,000 times, we have 1 minus V to the end, in this case is 3, divided by D, and that'll give us this bit over here. So we're dealing with 500, in outflows, negative 505,000. And the next bit is we're going to be using that formula that we had. Wonder if I actually can't get that to come over here. So here it is, what we're trying to use, that bit there. So we're saying, alright, so let's look at this. So if we say that V, and this is a different V now, so if we say V is equal to 1.06 divided by 1.07, like that, so that is our V for this bit over here. And that's all good. And then we're just trying to find out what I is equal to. So if we say equal to 1 divided by that, and then that minus 1, that is our effective I, taking into account our growth rate of 6%. So it's actually 0.9% per annum. And therefore our delta is equal to the natural log of 1 plus I, which is this I over here. And so they're very similar, but this is what we get, and that's what we care about. So let's look at the positive cash flows, and that's going to be 25,000 times 1 minus V to the end, so this is our V to the power of 25, divided by delta, which is this over here. And so that's what we get, and that's our positive cash flows. And so then we can say, is this bit positive? Well, actually, I don't need to say minus, it's just plus that negative number there. So we're getting this bit over here, 51,617.79. 51,617. So I think that's what we got as the answer. Yep. So that looks to be pretty good. Now, that's the first bit, so that's part I. Let's look at part double I. What does it want us to do? Calculate the discounted payback period of the project at an effective rate of interest of 7% per annum. So the discounted payback period, well, essentially all we're going to do is just make the negative equal the positive and then see what we get. So we need to find out how far, what we can make n to be to get this number over here. So I'm just going to keep that number, put it here, and say, alright, so now we just have to go backwards through this formula over here that we know. So we'd first have to multiply everything by delta. So that multiplied by delta over there. And in actual fact, I've also forgotten about this 25,000 over here. So we've got to divide everything by 25,000, which is that. And that actually doesn't have to be in a negative. So I'm going to get rid of that, multiply it by -1, because we're just we've moved the this bit onto the left-hand side of the equation. So it becomes a positive number and it's equal to this bit over here. So that's why I've just multiplied that by -1. Moving on from our formula, so we've got this bit over here, so that's saying that 1 minus v to the n is equal to this bit over here. So we just have to do 1 minus that over there, and then we have to find the natural log of this bit divided by the natural log of what we had with v, which is 1.06 divided by 1.07. And so we get 22.42 years. So that'll be n, 22.42. And all we really did was just did the exact same thing, but we made 25 equal n when we were doing that. And the reason I can leave this as a decimal rather than trying to round it up is because we're doing this continuously. So at any point in the year, it'll actually be 0.42 of a year after the 22nd year when this will be fully paid off. Okay? And now let's just have a look at part 3. It says calculate the annual effective rate of growth. So it wants us to find G of the net revenue, which would be required if the project is to have a 0 net present value at an effective rate of interest of 7% per annum. So all it's saying is pretend we don't know G. We're going to make this side, we're going to make this whole thing equal 0. So this will be 0, and we just need to find what G would be to do that. So let's figure that bit out. So basically, we know that when G is at 6%, so here there's 0.06, then we're going to get our present value of 51,000 over here. So G can actually be less. And we just need to find out what we can make G to bring it to 0. So let me I'll unbolt that and say this is what we're focusing on over here. We need to make this bit over here 0. So in order to do that, all we have to do is just see what numbers we can put in. And you can do this on the calculator. But if we just lower it by 1% and make that a 5, it actually goes negative. So let's see what G could be if we made it 5.1. It's still negative. And if we make it then 5.2, it becomes positive. So if we just said 5.13 or something like that, then we're looking at something that's just a little bit positive. So we can actually note that down as 5.13%, where G will be equal to 5.13% per annum continuously. And these are our answers, and that's it. So thank you very much for watching.